In this lecture, we shall consider the example of a cantilever beam with a point load at the tip combined with a uniformly distributed load over the entire length. The cantilever beam consisting of a point load P kilonewtons and a uniformly distributed load of W kilonewtons per meter over the entire length, both acting downwards, is drawn schematically and labeled as shown. The projection lines along with the zero datum lines for the shear force and the bending moment are also drawn. Now that the basics are clear, let's write the equations for the shear force at x and the bending moment at x straight away. The shear force at x equals plus P kilonewton plus W times x kilonewton and is valid for the entire length. That is, x is greater than or equal to 0 and is less than or equal to L. The maximum power of x in the equation is 1, meaning that the shear force varies linearly over the length. The shear force value for x equaling 0, that is the free end B, is found to be plus P, and for x equaling L, that is the fixed end A, is found to be plus P plus W times L kilonewtons, which is also the shear force maximum value. We plot the same and name the locus a linear curve. The bending moment at x equals minus P times x minus W times x squared over 2 kilonewton meter, which is valid for the entire length of the beam. The maximum power of x is found to be 2, which implies that the bending moment varies parabolically over the length of the beam. Let's find the values at the fixed and free end and plot the same in the bending moment diagram. For x equaling 0, that is point B, the bending moment equals 0, and for x equaling L, that is for point A, the bending moment equals minus P times L minus W times L squared over 2, which also happens to be the maximum bending moment. We take the double derivative of the bending moment equation with respect to x and find that it has a negative sign, meaning that the bending moment curve is of a maxima type. Let's plot the same in the bending moment diagram and name it accordingly. By slight investigation, you may observe that the shear force and bending moment diagrams obtained for this case are nothing but a superimposition of the shear force and bending moment diagrams of two cases of loadings that we investigated earlier, which is but a demonstration of the law of superposition applied to linear systems. In the next lecture, we shall consider the case of a uniformly varying load acting over the entire length of a cantilever beam.